Hi, physics. Mr. Janowski here. This is Chapter 13, Homework 5, Problem 6. And the question we've got is, to what radius would the Earth have to be contracted for its escape speed to equal the speed of light, which is always designated as a lowercase c, and c is equal to 3 times 10 to the 8th meters per second. And then we're going to draw its actual size on this page. So there's our answer, but we don't know the answer at the onset of this. So what are we doing? Step, huh? To what radius? So the thing we're looking for is going to be not the current radius of the Earth, the radius we need to squeeze the Earth down to in order to figure out, in order basically to turn the Earth into a black hole is what's going to happen here. So let me call that a capital R. So capital R is equal to question mark, and what units will the radius have? It'll be meters. It's a radius. So in order to do this, we're going to need our formula for escape velocity. So I'm going to do this without drawing a sketch. So the formula for escape velocity is v sub e is equal to the square root of 2 big G big M over the radius. So this is the formula we're going to use. Let me make it clear that this whole square root's over the whole thing. The thing we're trying to solve for here is the radius. And let me do one more little thing here. We're trying to make the escape speed equal to the speed of light, c. So we know that this is equal to c. So the next thing to do, ultimately we're trying to get r by itself on one side, is square both sides. That'll kill off the square root that we have here on this part here. So if we square both sides, we're going to get 2 big G big M over r, and on the right side, that'll give us c squared. So we just have to solve this for r. So let me draw a little arrow up to here. That would give us r is equal to 2 big G mass of the Earth over c squared. And then we just have to go for the numbers. So 2 times big G. Have you memorized big G yet? 6.67 times 10 to the minus 11th. Leave off the units, just be lazy. Times the mass of the Earth. The mass of the Earth is this number right here. 5.97 times 10 to the 24th. And the units for that are kilograms. And we're going to divide this by the speed of light squared. So 3.00 times 10 to the 8th meters per second squared. So when you do this in the calculator, make sure that you're only squaring this thing in the denominator. You're not going to square the whole thing. And if you do this, I'll skip the actual math part. You're going to get a fairly small number. You're going to get radius 0.00885 meters. And you can leave your answer like that. But if you know the metric abbreviations and the metric prefixes, so this is 885 thousandths of a meter is what's going on, because we're going to end up moving the decimal 1, 2, 3, which makes it a thousandth. So you can also write this the other way. Either way would be fine, but maybe easier to think of it this way. 8.85 millimeters. So put a box around it. Give it a check. So if you squeeze the Earth down to that size, you would have a black hole. So the last part of the instructions are draw at actual size on this page. So it's going to depend if this is the actual size of whether you're looking on this on a screen or on a phone, a computer screen or on a phone. But this is, let me do a little bit more metric, 0.885 centimeters. So this is a little bit, something with a radius of a little bit less than a centimeter. So on my screen at least, let me try to get this circle right. It would be something like that. That's not a circle. That's better. Ignore this. So we'll call this the circle. Yeah, so if you took the entire mass of the Earth and squeezed it down to something this size, um, this is our radius, 8.85 millimeters, you would turn the Earth into a black hole. So it's not likely to happen, but yeah, that's how you would do it. So this radius that we would turn the Earth, squeeze the Earth down into, this is what's called the Schwarzschild radius. It's in the slides. So hopefully you found that interesting.